Okay, I said the last video would include the Quine-Mccluskey method, but it was actually a long video. All of these are. So, and this is a long method, especially for this problem. So what I'm going to do is separate that out. This is the exact same expression as our 4-variable k-map. Now, the Quine-Mccluskey algorithm is good because it's something that could easily be mechanized. A computer can do that better than it can look at graphically a k-map and break it up. So what we're going to do here is it's an iterative process where we look at the numbers and find where the value changes by just one number, one input rather. And then we group these together, and by the end what we will have is a set of values that we can compare in a chart. And by looking at this chart, we can kind of knock out the ones that are doubles and find the essential values that we're looking for, the minimum number that we can use to represent that full truth table. So that'll make more sense as we go along. So here, what we want to do is look at all of the cases in which we have the numbers that are being represented here as decimal in binary, where they change by only one input at a time, one variable. So what we're going to do is say A, B, C, D, of course, are our inputs. So, and I'm going to have a number on this side. Now, I'm not going to do a full truth table here. You probably want to do that, but I'm saving space and trying to do this quickly. But you will eventually write down all of the values multiple times, in fact, for doing this method. So I've got my cheat sheet here of when I did it earlier, and we'll see how this works. What we're looking for are the essential prime implicates, which are the minterms that are basically the absolute minimum minterms that we can use to express all of the outputs. So what we're going to do is start with 0, 0, 0, 0. The reason is because that's our first input here, and that's a good starting point for looking at the numeric values. So we've got 0, 0, 0, 0. And of course, that represents the number 0. Now, there's nothing we can group with this. There's no value that we can easily group with that. So I'm going to draw a line here and look at the next set of values. So here, these are all 0 numerical values. In the next one, I'm going to write the next one here, which is 1. So 0, 0, 0, 1. Now, we're going to look for all of the other values that have only 1, 1 for each of these. So we have 1, we've got 2, 0, 0, 1, 0, and we have 8. And that's all. So now, let's look for the values that have 2 1s in them. So we have number 3, we have the number 5, and we have the number 10. Mark a line. Let's do the values that have 3 ones in them. We have 7, we have 14. And finally, here at the bottom, let's put our final value that has 4 ones in it. There's only one value with 4 ones in it, and that's 15. So, just like with 0, 15 is going to be by itself. So that's step 1. Step 2 is now a bit more complicated. We're going to make another listing here, and this listing is actually going to be a bit longer, but I'm going to group these in all the ways that only one value changes between them. Now that sounds confusing, but let's start with 0. So we'll group 0 with all of the values that is only one digit away from zeros. So let me kind of zoom in. My manual zoom here is a little iffy, but we'll see. So the first one is going to be 0 and 1. The only difference here is 1. So all of these 3 are zeros. So we will write 0, 0, 0. And then the one that changes that digit, I'm going to put a dash. And I'm going to continue to do that. So I have 0 and 2 now. So 0, 2. I have 0, 0, 0, 0, 0, 1. So that becomes a dash. And then 0, 0. I'm going to do the same thing for 8. So I have 0 and 8. The very first value is going to be a dash, and all of the rest are going to be zeros. So I've matched up all of the ones that are just one digit away from 0. So I'm going to put a line under that. I'm going to zoom out a bit. So now I'm going to start here, and I'm going to do the same thing with 1. So all of the values that are only one digit away from 0, 0, 0, 1. So I'll start with 1, comma. It's not going to be anything in 1's grouping here. It's going to have to be something else. So let's look here at 3. So we've got 0, 0, 0, 1. So that's a difference, but the last one is the same. So I'll put that down as 0, 0. This is the different one. This is the different digit between 1 and 3. So I'm going to put a dash and then a 1. The next one is 1 and 5. So I have 0. The only difference here is the B column. That's a 0 here and a 1 there, so that's the dash. Then I have a 0, 1. And that's all of the other ones that match up with 1. So now, let's look at the ones that match up with 2. And we have 2. And if we look down the line here, the only one that is only one digit away from 2 is 3. So we'll mark that as 0, 0, 1, dash. Actually, no, 10 also. Two and 10 are the same except for the very first bit here. So we have a dash, 0, 1, 0. And now we're done with 2's. So now let's look at 8. If we look at all of the values here that are only one digit away from 8, the only one that we can find is 10. Because we start with 1's, then B is 0, but the C column changes, and the D column is the same. So the only one that changes is the D column. So we have 8 and 10 are a match. So we will write 1, 0, and where it changes, of course, we're going to put a dash, 0. So now we are ready to move on from that grouping. Put a line under that. And we can move on to another piece of paper. So now if we look at 3, I'll go ahead and tell you that 3 and 7, if we look back at our original, 3, 0, 0, 1, 1 is only one value away, 0, 1, 1, 1 from 7. So back to here. 0. Oops. Fold the paper a little better here. So we've got 3 and 7, 0, dash, 1, 1. Then we have 5 and 7. And I want you to verify these on your own so you'll understand what I'm doing here. 1, dash, 1. And then we have a 10 and a 14. And that's 1, dash, 1, 0. Now again, that's just from this section. Oops. There we go. So this section. So I will put a line under these. And we can move on to the next section, the 7 and the 14 here. So what is only one value away from 7 that we haven't already listed here? We look here, the only thing that we can see is that 15 is one digit away from 7. So we have 7, 15, and that will be dash 111. And if we look at 14, again, the only one that we see that's one away from 14 that isn't already listed anywhere that we can see here is 15. So that would be 111 dash, because the only difference is the last column. Okay, and of course 15 is by itself. We're not going to do anything else with that because we've already matched it with stuff. So now we will do this again. As I said before, this is an iterative process. So what we're going to do is take these columns, this one with the dashes in it, and we're going to compare each of these groupings with each of the other groupings and find where only one value changes. Now this is a little complicated because what we end up having is not just a 0 or a 1, but we need to keep track of that dash as well. So, for example, and I'm just going to draw them or write them over here to kind of save a little time. I want you to, as I said, go back and hopefully you're taking notes. You can look at your notes and verify. I'm just going to give the values over here, and I'll explain them a bit. But I'm going to start a new column, and I'm using a different color. This is blue. And what we're going to do is match up here 0 and 1. So from our original 0, 1, we're going to look at 2 and 3. So 0, 1, and go all the way down here to 2, 3. So what we have is 0, 0, 0 dash for 0, 1. And for 2, 3, we have 0, 0, 1 dash. So in each column, everything is the same except for a single column. So in this first column, our zeros are the same. Second column, the zeros are the same. The last column, they're both dashes, so that's good. We matched up the dashes. But in this third column, we have a 0 in the first one here, and then we have a 1 in the 2, 3. So that now will become a new dash for our third step. So 0, 1, comma, 2, comma, 3. And the way we write it, again, the things that are consistent will stay consistent. So this 0 and that 0 match up. 0. This 0 and this 0 match up. 0. This dash, the last element here, and that dash are the same. So we're going to keep that dash. And now the one value that changes, in this case, from 0 to 1, we're going to add a dash in its place, just like we did for the very beginning. So our value here is 0, 0, dash, dash. And we can continue to do this. So we have another value here, 0, 2, 1, 3. That's interesting. These are the same values, the same numbers. So maybe we have a double there. We'll look at that in just a second. So looking at this, we got 0, 2. 0, 2 is 0, 0, dash 0. And then 1, 3 is 0, 0, dash 1. So in the first 3 columns, we have everything match up. And then the last one is where the change is. So we'll write the first 3 columns exactly as they are. 0, 0, dash. And then the last column, 0, changes to 1. So we'll put a dash because it changed here. And you'll see that these two are actually equal. Just keep that in mind for now. I'm going to go ahead and list the other values we have here. We've got a 0, comma 2, 8, comma 10, and that's going to be a dash 0 dash 0. We have 0, 8, 2, 10. That's going to give us dash 0 dash 0. And then that's going to be the end of this, the end of this grouping. So I put the line underneath it. Now we'll start with this grouping. So we'll start with 1, 3. And we match 1, 3 with 5, 7. We have 0 in the first columns. We have a change in the second column. Then we have dash and 1. So these match up except for the middle. So we'll have our output here will be, this is 1, 3, should be 5, 7. We should have 0 dash dash 1. The next value, and luckily our last value that matches here is 1, 5, 3, 7. And if we look here again, we will have zeros dash dash 0. Now, we didn't really use all of these. We didn't really use all of these first ones in the second one. So, what you could do, probably easiest to do this as you're using them. If you use a grouping like this 0, 1, mark it. That way, you know you've already used it. And the reason is because if we mark it, we'll notice that there's some of these that don't get used at all in our newest column. Those are important. We're going to need those, as well as our latest column, to make a chart. So here we have used, also in the very beginning, if we don't use all of these in here, then we would have to note it. But in our case, we actually did use all of those. So I'm going to just leave it blank. I'm not even going to mark through every single one of them. But it's important. We're going to mark through a lot of these other ones. But it's important to know which ones we do and which ones we don't. So we used 0, 1 here. Like, there we go. So we use 0, 1 here. 0, 1. So I'm going to mark through it. Of course, you can't see that. Let me get a better marker. There. Okay, so we use 0, 1, we use 0, 2, we use 0, 8, we used 1, 3, 1, 3, we used 1, 5, 1, 5 is at the bottom down here, we used 2, 3 in the first one, we used 2, 10 in this one, we used 8, 10 in this one. So we've used up all of those. Now let's look at these. We used 3, 7 in this last one here. And we used 5, 7 in the second to last one. So the ones that we did not use are the only ones that are left to us here. So we didn't use any of these values at all. We didn't use any of these values at all in making the new ones. And then of course our new ones are the ones that are left. So, and this was a 3-step process so far. So we start with step 1, where we compare, we write down what we have, our values here. And then step 2 is comparing to see where the first change occurs. This is the dash, the first dash. So all of these numbers should have at least one, or they should have only one dash in them. This third iteration should have 2 dashes in every one of these numbers. And you can move on and on, 4th iteration and so forth. It just so happens that we don't have any of those. If you look here, there's no case where it's the same in 3 rows and only different in 1 row. So that's why we stopped at this point. But you could continue on conceivably and get more and more values. Now this is especially more important when you're doing more variables than just 4. Because it's very hard to represent those as a K-map. But those 4 variables could easily go through this process. Since it's an iterative process, you can just break down step by step until you're done. So let me rip this off and flip it around. Okay, so this paper has all of our prime implicants in it. So now let's actually represent this in our chart that I mentioned multiple times. So for each one of these, I'm actually going to list them in a column here. And it may be best to do this long ways. How can I do this long ways? I'll do it this way. That's about the only way I can really conceivably move the paper. So, all right, so first I'm going to start off with our first value from here. I'm going to list these groupings, and then I'm going to list these groupings, and then we'll make the chart overall. So the first grouping is 0, 1, 2, 3. Since I have this as a grouping, then I will do 0, 2, 8, 10. Then I have 1, 3, 5, 7. Oh, and that's something else I forgot to mention. So since we have two that are the same, we can use one or the other. We don't need to use both, because they both equal the exact same values there. So that's why here I've got 0, 1, 2, 3, and not 0, 2, 1, 3 as well. So, and that's the same with the 0, 2, 8, 10 value here as well. 0, 2, 8, 10 equals the same thing as 0, 8, 2, 10. So I told you we were going to talk about that a little. But notice we have to use both the 1, 3, 5, 7 and the 1, 5, 3, 7 here, because they're not equal. Wait a second. They should be equal. Yep. Okay. This should be a 1. Yeah. Okay, so that should be a 1. Back to this guy. We only use one of those here. So 1, 3, 5, 7. And we should also use the smaller grouping that was not used up in our third iteration, our third step there. So these three values, all three of those. So we'll put here, that's 10, 14, 7, 15, and finally 14, 15. And at the top of this chart, I'm going to list all of the outputs that give us, or all of the values that give us a 1 for our Boolean expression. So if we look back at our original problem, it's 0, 1, 2, 3, 5, 7, 8, 10, 14, and 15. So 0, 1, 2, 3, 5. Oh, come back here. 7, 8, 10, 14, and 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's all of them. And these are small columns, but all we're really doing here is we're going to represent an X wherever these exist. So we're in the 0 column. This first one has a 0. I'm going to put an X here. And this next one has a 0. I'm going to put an X there. But these other ones don't have zeros. The next one, this has a 1. This one does not. This one has a 1. And those do not. If we look at 2s, this has a 2. This one has a 2. And none of the others have a 2. Look at 3s. This has a 3. This has a 3. And none of those have 3s. We look at 5s, not that one, not that one. This one has a 5. This one does not, this one does not, that one does not. We look for 7s. So this has now got a 7 in it. So we mark an X over the 7. None of the others have 7s. We look for an 8. So we go back to this one. Has an 8 in it. So we mark the 8. That does not. That does not. So now we look for 10. This one has a 10. That's the only one with the 10. We look for 14. This one has a 14. This one also has a 14. So we'll mark a 14. And now we look for 15s. So the last two have 15s. So at this step, we're looking at the columns. We're going to try to find the cases that don't have doubles. So starting from the top, this has a double here and a double here. So I'm just going to mark it out. This next one, now that I've marked this out, has no doubles at all. So I'm going to keep it. That means none of the X's appear in any column more than once. We look at the very next one. It's the same case here. Since this is already marked out, it no longer exists. So we can say that this X is the only X in this column. And the same for those three columns too. This next one, we have 10, 14. 10 I skipped one because this has a 10 in it. So let me mark that 10. Okay. Since I'm keeping this 10, because these are the only X's that are represented in these columns. So I need to keep these 10s. So I'm going to mark out that row because there's a double there, but the only other one that's doubled, the only other one that is marked here also has a double. So it's actually not recommended to have more than one X in a column at all. So if we look there, and I missed, this one has a 7. So that's a double there. And again, if I look at the doubles, this has a double in the sevens column, but this row, has other x's that do not have doubles in the columns. So that means that this one is a prime implicant, or an essential prime implicant. And this one, since it has a double at 7, the only other value it has is 15, and that is a double as well. I'm going to mark that one out. And finally, this last one, I'm going to keep, because it's x, x, and there's nothing else in these columns since I've marked these out. So, in the end over here, what I can do is, now I can write the values that I'm looking for. So I'm going to write the representation of 0 to 8, 10 from our column over there. So 0 to 8, 10, because that's a survivor. We're going to put, that is this dash 0 dash 0. The next survivor is 1357. Was 0 dash dash 1, and 1415 it was 111 dash. I'm sure I'm confusing you greatly at this point. So we're at the very end here. If we remember that each of these values represent A, B, C, and D, we can use this to come up with the final Boolean expression. And what we're going to do is ignore the dashes. The dashes don't exist. And we're going to keep the idea, just as with K-maps, that 1 in that column represents that value, and 0 represents that inverse. So for here, we would skip this one because it's a dash. This next one has a 0 in the A column, so I'm going to say that is A naught. And this last one has a 1, so I'm going to say that is equal to A. In the second column, we're looking at B's now. This one, I'm going to say is equal to B naught. That's a goofy looking B. So I'm going to make that a little bit more like a B. So that's B naught. And this one, it's a dash, so we're going to ignore it. Here, it is a 1, so that is going to be a B. This third column here, it's a dash, and this one we're going to ignore it. A dash here, we're going to ignore it. And then the last one, it's a C. And finally, we have a 0 in the D column here, so that is a D naught. Here we have a 1 in the D column, so that is a D. And a dash in the final D column, and that is going to be ignored. So, what does all this mean? What is it for? Here it is. If we go back to our K-map, which is much easier for humans to read, the values that we came up with from our K-map are B naught, D naught, B naught, D naught, A naught, D, A naught, D, and A, B, C. A, B, C. So the two methods are equivalent. K-maps are easier visually for humans to identify the groupings of ones, and the Quine-Mccluskey is much better for computers. So we have an iterative method that you can go step by step comparing a single change in a bit to find out whether it's one value or another, and then do that over and over again, make sets or groupings of values, and then compare them in a chart like this to see which ones are the essential prime implicants. So you can't represent this with any fewer values. This is the absolute minimum for this expression. So I hope you learned something without being confused too badly. So please email me. I know you will. But please email me any of your questions. Thanks.